In this video, you'll learn how to carry out a safe and efficient internal blade inspection using the crawler robot. We'll walk you through blade access procedures, essential safety checks, operating the robot, and working both from the hub and inside the blade. This training is designed to get you field ready with confidence and provide a comprehensive overview of the entire process. The standard KPI, or Key Performance Indicator, for internal blade inspection is the time from the start of work until the end of all tasks on the turbine. The target time for the full process is around 3 hours. This includes approximately 45 minutes for setup, an hour and a half for the inspection itself, and about 35 minutes for packing up and closing the turbine. Note, actual times may vary depending on the turbine model, blade size, site conditions, and client-specific procedures. Step 1 starts with arriving to the correct turbine. Match the wind turbine ID with your Aerotask ticket, then complete the required site check-in. This could be an email or phone call to the wind park dispatcher to confirm the start of work and avoid overlaps with other teams. Next, start the ticket in Aerotask. Take a photo showing the tower ID. The photo of the turbine must include a clear view of the tower structure and its identification number, ensuring it's fully visible and readable. Next, gather the team for a job safety analysis. This is required before any physical tasks begin. Review weather conditions, discuss site-specific risks, and confirm emergency procedures. Once the JSA is signed, start the IN setup timer and proceed with the inspection setup tasks. Start the setup timer, and always check the latest weather conditions before proceeding. Step 2 focuses on safely shutting down the turbine. Using the main control panel, switch the turbine to off and set the control mode to repair, maintenance, or safe mode, depending on the turbine type. Immediately start the turbine off timer in Aerotask. Then, apply all necessary lockout-tagout devices according to the site's procedure. This ensures the system remains secure while work is being performed, and ensures that if there is an overlap in teams waiting to work on the same turbine, you have visual signs that show that there's another team already working. Step 3 is your final emergency and access check before work begins. Start by reviewing the turbine's emergency plan. Make sure it's specific to this site and every team member knows the evacuation procedure. Confirm that a first aid kit is fully stocked and accessible. Next, check that the fire extinguisher is present, visible, and inspected. Finally, verify that both the elevator and ladder have valid certification. If the lift is expired, but the ladder is certified, work may continue, but only if it's documented in the JSA and your team is trained for ladder-only access and rescue. However, if the ladder is expired, you must not enter the turbine. A certified escape route is mandatory under both company and industry safety standards. Step 4. This is your final moment to review the job safety analysis before starting the work. If anything changes, like weather, access routes, or team composition, you must document it in the JSA. This is also the time to do your last daily check on PPE. Make sure your harness, lanyards, gas meter, and communication devices are ready, and confirm that your whole team is fully prepared and aligned before moving forward. Step 5 focuses on safe vehicle positioning. Your car must be parked outside the drop zone. That's at least 25% of the tower's height, depending on the turbine model. For example, if the tower is 120 meters tall, you must park at least 30 meters away. Always position your vehicle facing the exit to allow for a quick evacuation in case of an emergency. Never park under the blade sweep area or near lifting operations. Keep the path between the vehicle and turbine clear at all times, and make sure emergency equipment in the vehicle is easily accessible. Step 6 is about safely moving your equipment to the nacelle. Start by packing all your tools, the crawler, and safety gear. Make sure you have everything you need. Check for batteries, blade hatch tools, PPE, and anything else required for the job. Always think ahead. Bring what you need so you don't have to come back down. The team should always make at least a mental inventory checklist of what they bring up. This helps avoid leaving anything behind, especially in areas like the hub or blade, where forgotten tools can cause serious damage. You have two options to transport the equipment. If the elevator is working, certified, and approved for use on site, you can use it to bring up the bags. Just make sure to stay within the lift's weight limit. If the elevator can't be used, or if the equipment is too heavy, you'll need to hoist it using the chain hoist and a certified lifting bag. This must be done by a trained person using properly inspected gear, and the lifting bag must be secured to a certified anchor point. Clear communication between team members is essential during the lift. Never carry heavy gear up ladders. Always use certified equipment and follow what's written in your JSA. Step 7 is all about getting to the nacelle and making sure it's safe before stopping the blade. Start by ascending using the elevator, but only if it's certified, inspected, and approved for use. Make sure you know the emergency evacuation process in case of lift failure. If the lift isn't available, climb using fall protection and take your time. Once you've reached the nacelle, switch the yaw system to manual to avoid any unexpected movement. In some turbines, this can already be done from downstairs. Doing this early reduces the movement of the tower while using the elevator. Take time to inspect your surroundings. Make sure anchor points are certified. Check for any loose tools, abnormal noises, or anything that feels off. Finally, communicate with your team and confirm that everything is secure. Do not begin blade stopping or hub entry until you have confirmed that the nacelle is safe, secure, and ready for work. In GE turbines, you can connect your laptop directly to the turbine network using an Ethernet cable, as long as you have the correct IP address. This allows you to monitor live wind speed, turbine status, and view faults or alarms in real time. In Vestas turbines, the same monitoring can typically be done through the control panel, which displays current wind conditions and system status without needing an external device. Step 8. Start by rotating the blade into the correct position, typically horizontal at 9 o'clock. Next, apply the rotor lock and follow the full lodo procedure to secure the hub and prevent any blade movement while someone is inside. If your turbine has a hub safe mode, activate it now. In GE turbines, this includes turning the key on the rotor lock bypass panel to the right. This prevents any uncommanded pitching. Once everything is locked out, complete the lodo documentation and confirm it with your team. Do a final check on the crawler if needed. When setup is complete, stop the IIN setup timer and start the blade inspection timer. You're now ready to proceed to the hub and begin the internal blade inspection. Step 9 is about safely moving from the nacelle into the hub. Before crossing, confirm that rotor lock, yaw manual mode, and hub safe mode are active. In GE turbines, you'll often need to hand equipment bags across an open space, which introduces fall risk. When handling bags in this situation, always secure them by attaching to an anchor point using a lanyard or carabiner connected to a lifeline. Stay clipped in at all times and make sure all gear is secured before crossing. In Vestas turbines, entry usually involves passing through tight spaces around the curved hub shell. Watch for trip hazards, maintain 3 points of contact, and take your time. Before entering the hub, test the air using your gas meter and inspect the space for loose objects, oil leaks, or signs of damage. If required by site or turbine model, install the LPS bridge before beginning blade work. Always treat the hub as a confined space, and only enter once you've confirmed it's safe and secure. Step 10 is where the internal blade inspection begins. The blade and hub are considered confined spaces, so make sure your confined space permit is filled out and signed. Before entering, turn on your gas meter, let it calibrate in clean air, and use it to test the air quality inside the hub and blade. Always stay connected to a certified anchor point with your lanyard or lifeline whenever there's a fall risk or you're stepping into the blade. The same applies to equipment bags. If there's a risk of dropping them, they must be secured to an anchor point at all times. Next, start your blade documentation. Measure the distance to the RCO, inspect the LPS cable, look for any root anomalies, and record the blade ID and serial number. Take photos to document each of these steps. Carefully hand the crawler inside the blade, then prepare the rest of the equipment, including the antenna and remote control. Attach the fishing reel securely to the robot. Open the GoPro app and verify that 360 video mode is enabled and the settings are correct. If needed, clean the camera lenses and LiDAR to ensure clear visuals. Adjust the speed dial to inspection speed and set the LED brightness to maximum. Before recording, place the whiteboard in view of the 360 camera with all relevant turbine information, including turbine ID, blade section identification, and date. Begin the inspection recording in continuous video and read it aloud for the camera. Pause to take still images if you find any excessive damage or out-of-ordinary defects. Step 11 is about packing up and closing the blade hatch after the inspection. Pack up the crawler, disconnect the antenna, turn off the camera, and store all components safely in the equipment bags. Take all tools and equipment with you. Nothing should be left inside the blade. Close and lock the blade hatch securely. Then take a clear photo of the closed hatch with the Aerones application. Step 12 is about closing and securing the hub hatch after completing blade work. Start by removing the LPS bridge if one was installed and store it with your equipment. Make sure the hub is completely clear. No tools, bags, or personnel should be left behind. Then close and secure the hub hatch. Lock it according to the procedure and perform a quick check to confirm it's sealed properly. Finally, take a photo of the closed and secured hub hatch and upload it to Aerones. When that's done, stop the inspection timer for blade inspection. Step 13 takes place after all blade inspections are complete. Stop the IIN timer and begin your packing up timer. Close the nacelle roof hatch and confirm it's sealed. Don't forget to take a photo for documentation. If any other hatches were used during the inspection, now's the time to close and secure them. Complete your confined space permit and upload a photo of the filled form if required. Mark the CS entry process as complete in Aerones. Next, verify that it's safe to remove LOTO. Remove all applied locks and tags and finish the LOTO permit in full. Finally, remove the batteries and memory cards from the crawler and pack them into your equipment bags for safe transport. After all work zones are confirmed clear. Then, switch yaw mode back to auto. If hub safe mode was used, turn it off now to allow full system reactivation. And if possible, make sure the turbine responds normally. Step 15 is your final check before leaving the nacelle. Bring all equipment down to the lower platform and close the hatch behind you. If your turbine is equipped with mobile ladders, return them to the parked or folded position. Take a photo showing that the nacelle ladder is properly secured and another photo confirming that the hatch is fully closed. Every nacelle hatch you open must also be closed, with photo proof uploaded to the Aerones app. These are your last documentation steps before safely returning to ground level. Step 16 is where you power the turbine back on. Use the control panel to start and wait for confirmation that the system is running. Once the turbine is reactivated, stop the WTG off timer in Aerones and make sure the entry is logged. Only reactivate the turbine when all work areas are clear. LOTO has been removed. Turn off tower lights before heading out. Step 17 is the last step of the job. Once everything is packed, stop the packing up timer in Aerones to finalize your work time. Then, take 2 key photos, one of the turbine's control panel showing that it's active and one of the closed and secured tower door. Before you leave, make sure no equipment or materials are left at the site. Upload all required documentation to Aerones, notify your coordinator or dispatcher if needed, and confirm that the turbine is back online and running. You're now clear to leave the turbine site. The inspection is complete.